From here in London, thank you for joining us for today's webinar with a manufacturing focus. The topic of today's talk, we'll be looking at industrializing additive manufacturing through an integrated end-to-end process. Just some housekeeping, if you will, then audio is provided to your computer, speakers or headphones are required. If you do get disconnected, you can reconnect using the link that I would have sent you via email. And during the event, you can send comments to myself. My name is Jay Dunstan. You can communicate with me using the chat window. Essentially, I am your host. And also, questions will be taken at the end of the hour. Our expert has been kind enough to donate some of his time to answering your questions. I would encourage you to take and make full use of that. If you see anything you'd like us to clarify, to highlight, to dive deep into for you, then please feel free to send in your questions. Okay, a very brief bio, corporate bio, if you will. Welcome to Siemens PLM Software. We are the business unit of Siemens Digital Factory Division and a leading global provider of software systems and services. We have over 15 million licenses sold and around about 140,000 customers and counting. We're headquartered in Plano, Texas, and we work collaboratively with clients to offer industrial software solutions that help companies worldwide to achieve a competitive edge in their designs. Okay, that's our corporate bio over with, if you will. I'm delighted to have as our speaker Mr. Ashley Eckhoff. Ashley has worked for Siemens for well over 20 years within several capacities. He has spent the last 3 years deep diving into additive manufacturing, initially as an NX product manager and now as a marketing manager for the manufacturing engineering group. Okay, so that's your speaker today. And with that, I'd like to hand over to Ashley Eckhoff. Okay, Ashley, just passed you the ball, and I can see you've unmuted yourself if you'd like to go ahead and share.
Sounds good. Thank you, Jay.
Okay, you're good to go.
Thank you. And thank you to all of you for joining us today. I really appreciate taking time out of your day to look at what we have going with Additive. Going to start out today by just doing a little bookkeeping of my own. This is actually the second in a series of webinars. The first one was a recorded webinar, which you can find on our webpage. It was basically a teaser for this webinar, so a shorter version of this, not as deep in some of the various different topics we're going to talk about. However, if you want to go even deeper than that, we have other webinars coming up. In April, we have one on manufacturing for additive manufacturing. It sounds a little redundant, but in that one, we're talking about the actual process of additive manufacturing within the software. So build tray setup, support structures, 3D nesting, actual connections to printers, the types of hardware we service, all those things. We'll be talking about some of that today, but this webinar in April is a deep dive into that, so much more detailed on those subjects. In May, likewise, we have one that's a deep dive into the design side. So that'll be talking about design for additive manufacturing, lattice structures, probably some topology optimization, things like that. So again, we'll touch on those subjects today as part of our end-to-end process we're going to talk about. But if you'd like a deep dive into those subjects, May is the time to look for that webinar. And then I think, we don't have it officially on the calendar yet, but I think we'll probably have another one in June to kind of round out the set. That one will be simulation for additive manufacturing. So you'll probably talk about topology optimization there as well, but some of the other simulation types. So, thermal flow, structural simulation, and probably even process simulation during that one. So hopefully we'll get that on the schedule here soon, and you'll see that one pop up. Also, should you happen to be interested, next week we have another webinar that it deals with additive manufacturing, but it's with a bent towards machine shops who might be looking to adopt additive manufacturing as one of their manufacturing processes. And we'll have a guest speaker during that webinar. Our friends at HP will be talking then as well. So lots going on in the additive manufacturing area as far as webinars. And I'll give you a link at the end of this webinar where you can get some ideas about what's coming up for our webinars and everything else we have going on. So to get things started today, as Jay said, we at Siemens are a pretty large company, but one of the good things about that is that we have a long history with additive manufacturing, going back to the very beginnings of the technology. And we don't just write software for 3D printing, but we also use it in our everyday work. And I'm going to talk about some examples later on in better detail, but just to kind of give you a level set, there are divisions of Siemens who are printing real production parts as part of their business. In the UK, we have a division called Material Solutions who print exceptionally high quality metal parts on a daily basis. They're part of the team who printed the Siemens turbine blade, which has won several awards over the past year. We also have a team in Sweden who uses additive manufacturing to repair gas burner heads. They use a special additive manufacturing process to repair these. Saves them large amounts of money, and it gets broken parts back into service faster than they would have been before. Then in our mobility division, we're printing custom parts for various different solutions, similar to the train control arms shown here. In this case, we have different customers who have different requirements and different situations, and they need custom solutions. So 3D printing is one way that we handle that complexity. So as I said, Siemens, we don't just write software. We actually make these parts, and then we try to take the knowledge from building 3D printed parts and put that back into the process when we design our software. So as we think about the opportunity with additive manufacturing, we think about that taking several forms. So we sort of talk about this as, we believe that companies who adopt additive manufacturing have this opportunity to reimagine their products, reinvent their manufacturing, and rethink how they do business. So on the design side, what we're seeing is a need for companies to reimagine their products for this new additive manufacturing technology. And this means not just modifying an existing design so that it prints properly, but actually rethinking a part, redesigning it from the ground up to take advantage of the capabilities that additive manufacturing brings to the table. With anything less than a full redesign, you can get small gains, but you won't really get the full potential of additive manufacturing. Then on the production side, we see companies evaluating their processes and looking for ways that additive manufacturing can help augment and streamline those manufacturing processes. So people eliminating moldings and castings and other long lead time types of manufacturing with additive manufacturing. We see them eliminating a bunch of assembly processes by taking complex assemblies and merging them into a single part or fewer parts using additive manufacturing. Things like that are helping people take their manufacturing processes and evolve them to include what additive manufacturing brings to the table. And then, finally, once the companies have started thinking about their designs differently, they've started manufacturing things differently, we see them begin to think about how all of these new capabilities combined can affect their business. So what are the opportunities for new products, new efficiencies, new innovations that additive manufacturing brings to the table? Can we now, print custom products because we can do a lot size of one much more inexpensively than we could before? Can we do zero inventory where we print these things on demand rather than having a huge warehouse? So once companies have gone through this process of reimagining their products, reinventing their manufacturing, and rethinking their business, then they can begin to see the full potential of additive manufacturing pay off. Now, that being said, when we look at the additive manufacturing landscape and we talk to various different players in the industry, we also see lots of barriers to industrializing additive manufacturing. And the largest barrier is this disconnected process chain. We commonly talk to customers who have 4 or 5 and sometimes even as many as 8 different software products that they use to complete their additive manufacturing workflow. Now, each new piece of software they use requires a data translation. It introduces the chance for errors and sometimes even reduces the quality of the data that's being passed between the different stages of these workflows. And furthermore, many industries like defense and medical require traceability of the data from the initial design all the way through to the manufacturing. So, if something happens out in the field, they can trace that problem back to wherever it started in the process. But this becomes really difficult when you have such a disjointed process here. So the result of this is that a lot of the companies we talk to feel like they're less efficient than they could be, that the process they have is more prone to error. So At Siemens, we're working towards fully industrialized additive manufacturing, and this means that the entire process chain must be integrated in order to allow for a smooth, lossless exchange of data between the various different processes in the workflow. So data from every step of the process must be handled and managed along with the data from the previous steps. This sort of tightly integrated process leads to a proper, uninterrupted, what we call a digital thread from design to manufacturing, bringing about higher quality, more efficiency, and true traceability. So we believe that for additive manufacturing to be a truly industrial process, you need to have a tightly controlled industrial workflow to go along with that process. Now, we've begun working towards that end by building the necessary pieces of software into our NX suite of products. On the design side, we've introduced a technology we call Convergent modeling technology, and this allows you to manipulate CAD data with native processes, regardless of that data's origin. So facet bodies, scan data, native CAD data can all interact seamlessly using the same tools you'd use just with CAD data alone. So in this series of images here, we have this part, and this part came from one of our partners as STL data. So it's just a facet body, right? But we need to do some changes. We need to make some changes to that. We want to remodel this little cone-shaped diffuser that's at the end there on the left, and we want to include some fins to help direct airflow. So to do that, the first thing we have to do is remove the old cone. So in a facet modeling system, this will require you selecting a bunch of facets, possibly even individually, depending on how close they are to other things, deleting them, and then healing the geometry. So with NX, we don't need to go through those steps. We simply just create a cylinder using our normal CAD operations, and then subtract that geometry from the facet body. So it just chunks it out, and the system handles all of the intersections and the healing of the facet body automatically. Then we design a new cone with the desired fins using normal CAD modeling techniques, and this makes a native CAD BREP geometry, which is that green thing you see there. And then the final step is just to unite those back together. So this whole process is seamless and easy. The CAD operations, such as the subtract and unite, work without regard to what kind of data they're represented with. And the end result is a system that saves an enormous amount of effort and time when dealing with the types of geometry that we commonly see in additive manufacturing applications. So if you're familiar with things like lattice structure generators and topology optimization, those types of tools often result in facet data. So being able to use that resultant data with native CAD data is really powerful. And this functionality is extremely important for companies who are getting data from external sources, right? So like if you have customers of your own and they're sending you things and you're editing that data for use with additive manufacturing processes, this can be really powerful for that as well, because lots of companies spend a huge amount of time editing the geometry their customers provide to make sure that it prints properly. And we've seen cases where convergent modeling can save up to 50% of the time spent in this process. So this is a video, and just to warn you guys, these videos I have today are pretty short and sweet. Like I said, the topics we're going to talk about in these videos are things that we'll deep dive into in later webinars. So for today, we're kind of touching on these things, giving you a teaser, and then we'll deep dive on these in other webinars. But so this is sort of seeing that process in action. We've taken that duct, we're going to create a cone and subtract it. So there that we subtracted down at the bottom the little cone. We're adding a new one in with veins. We just hit unite, and boom, we have a final product where we had the original STL geometry and some new CAD geometry all united together in the same part. And it's as quick as that. There's really no mystery at all from a user standpoint. It just works, right? So taking this kind of geometry and using them together is something that's unique to Siemens NX, but again, very powerful for lots of these additive manufacturing applications that we see with things like facet bodies. So continuing the theme of providing a fully integrated tool set for additive manufacturing, we've also integrated topology optimization into our tool. So for people who wish to optimize their designs, you can do that without, again, breaking the nice digital chain of data from the beginning to the end. So it's worth noting here that as topology optimization becomes more mainstream, the number of companies needing to manufacture parts like these is going to increase. And in many cases, the organically shaped parts that result from topology optimization and other generative design techniques are pretty much impossible to manufacture using traditional methods, or if you do, it's pretty difficult. So to manufacture parts like these, you really need additive manufacturing. So to look at what this looks like inside of NX, here we're inside NX again with the original part, sort of a bracket. And what we're going to do is we're going to create a work envelope around that bracket. The pink area you see here, it defines the extents of the final part. Red area is keep out area, and the blue areas are pens. And what we're going to do is we're going to assign a material. So I think we already have it assigned in this case, but we're going to assign a material steel. And then we're just going to tell the system to run. Now, in the background, I've done some other things like set up a few loads, but in reality, there's not a whole lot more than what you see here. And again, we'll be deep diving into this in another webinar later here in a month or so. But you tell the system to run. It's going to go use those loads, the conditions you've given it there, the bounding areas, the keep outs, the pins, those sorts of things. It's going to have a look at all of that, and it's going to create an optimized part that's also been analyzed automatically for strength and deformation. So the system is going to run here, and again, this is all nicely integrated. So the part that results from this can be put directly back into your assembly inside of NX. Again, no data translations, no back and forth with other software packages. It's all built in and results in these nice, smooth parts that can be used directly inside of an NX assembly. Now, of course, Siemens also has a strong set of traditional analysis tools to ensure that the final design will meet your specifications. We have a long history of providing robust analysis tools for things like thermal analysis, flow, vibration, acoustic simulation. Between NX Simcenter, LMS, FEMAP, Star CCM Plus, and others, we definitely have whatever simulation and analysis tools you need to ensure that your product's performance in the field is what you expect it to be. So in this case, we've taken that same duct, we've done a fluid flow analysis. But like I said, there are other standard analyses available inside of NX. We've got all the standard ones you'd expect to be there. Now, even if your company doesn't design parts, but instead provides the manufacturing operations for your customers, a lot of times simulation is still important because as the original customer designs are modified to fit the manufacturing process, you want to ensure that those edits that are made don't affect the performance of the part in the field. So having these capabilities integrated into the system, whether you design parts or not, having those integrated into the system you already use saves you a lot of time and effort. And again, so we've got quite a few different simulation tools available inside of NX. And again, it's all a seamless process to analyze the data that you already have in the system. Now, depending on the printing process, various steps must be taken to set up the proper build job before printing. So, for example, with HP's multi-jet fusion technology, functions like the 3D nesting you see on the left in the build tray become immensely important for executing that process efficiently. For other technologies like metal printing, the generation of support structures is necessary for proper output. And then depending on the printer type, you may also be able to set slicing, hatching, and path generation strategies inside of NX. So having all these functions built in means that you never lose that data fidelity or the traceability throughout the entire process, like we talked about before. So here's a video of our nesting capability. So again, in this case, we have the same duct part and another part that we're nesting here. And like I said, this is really useful for printers like, for example, the HP multi-jet fusion printers. To maximize the efficiency of that type of printer, you want to pack as many parts as possible into the build volume, and then you want to push them down towards the build tray as far as possible. So our system does this by you give it limits on how close the parts can be. You instruct the system to optimize according to minimum height. And as you can see, the process is fairly automatic. You give the system those inputs, you tell the system to go, how long you want it to process, and the result is a tightly packed build tray ready for printing. Now, if you're using a metal powder bed machine, you might then apply some support structures, although for the HP this isn't necessary, so we didn't do it here. But again, this is all integrated tightly into NX, so there's no need for external tools to perform these operations like you might use today. And here we have a build tray. We're going to place the topology optimized part that we created before onto the tray. And since this part's slated to be printed in metal, we're not going to 3D nest it, but we're rather just going to manually place it in the tray. We move it up slightly from the build surface so that when we remove it from the tray, we're not cutting into the actual part. And then we create some support geometry. And again, this is all being done inside of Siemens NX, so there's no need to jump to an external system. Now, the real advantage of this is that if the part geometry changes, you can automatically regenerate the support structures. And this is the type of associativity that you don't get when you have that broken process chain with the 5 different products we talked about earlier. In this case, you just update the part, let the associativity take care of updating the downstream geometry like the support structures. Something that saves a ton of time and, again, reduces that chance for error. You don't have to rebuild things. It all just works seamlessly. So finally, once you have your build tray set up, you need to print it, right? You need to print the final part. So again, this is an integrated process for Siemens NX. You simply select the printer you wish to use and set up your build tray like we saw before. Set some parameters, so the material you're using, the cooling profile, other things like that. And finally, you just print, at which point we hand the process off to integrated build processors, and those create the proper data and instructions to drive the various different printers we support. Again, an integrated process that's completely handled within the Siemens NX system. You don't have to jump out to software that was provided by your printer manufacturer or anything like that. But you have this complete workflow from the initial design through the analysis, through the optimization, to the build tray setup, and finally production. And all that data is tightly managed. Process can be completely industrialized. So having seen the entire process from design to print, it's worth talking about the types of hardware we support. So from standard planar powder bed fusion products that we see quite often in the market down there in the lower left, and that includes plastic as well, because I guess the HP multi-jet fusion can really be considered a planar powder bed. So we support those, and then we also support some very interesting new technologies that are multi-axis. So we've got the hybrid directed energy deposition up on the upper left, and some fused deposition modeling we worked on with Stratasys on the right at the top. Those are both multi-axis types of printing, which we're starting to see a lot more people taking a look at. So we're partnering with various different people to make sure we have the capabilities we need to support the widest range of 3D printing hardware possible. Now, some companies would like you to think that once the part's been printed, this is the end of the story. You can just box it, ship it, and you're done. But in most cases, honestly, that's not true. Metal parts especially almost always require post-processing with machining or other operations to achieve the required finishes and tolerances. And honestly, parts of any kind should be validated to ensure that the final produced part meets the initial requirements. So this is another case where having additive manufacturing functions integrated into a full CAD system pays off, because Siemens NX has all the functions necessary for post-processed machining and final part validation of your additive manufactured parts. So this means that you can program your additive and subtractive operations as well as perform your validation all within our system. And that way there's less to learn, less chance for error, better quality, faster turnaround, all the benefits you'd come to expect from such a streamlined process. So to make all this happen, we've teamed up with what we consider to be the world's leaders in additive manufacturing equipment and technology. This is because we realize the importance of maximizing the value of our customers' investment in this AM equipment and their process. So we understand that our customers will often require multiple different productions, additive manufacturing productions, or technologies to make their production. And so This has driven us to partner with the best technology companies in the industry. Now, these companies have years and sometimes decades of experience in the industry, and this is why we partner with them to bring our end-to-end solution to life. So what we've seen here is that Siemens PLM software system provides the solution for true industrialization of additive manufacturing. You start with the design, ending with the final validation of the part. Our system includes all of those processes necessary to complete the additive manufacturing workflow, and you can see those steps here from beginning to end. Now, this fully integrated system for additive manufacturing includes NX, Simcenter, Teamcenter, right? Our standard package of CAD and data management tools, supporting the entire process, the CAD, the CAE, the additive manufacturing, the CAM, all in one place, and easily incorporating design changes with associativity between the different steps, the design stages, the production stages. All of this bringing us to what we consider to be a truly industrial production system for additive manufacturing. Now, I mentioned before that Siemens doesn't just write software, that we actually print parts as part of our daily work. So how does all of this play out in the real world? So at Siemens, our manufacturing businesses are designing for additive manufacturing, and we're 3D printing production parts that go into end products. A major component of any gas turbine are its burners. And one example of this is the SGT 800, which is what you see down there on the lower right from Siemens. This is from our power generation division, and it's their most efficient gas turbine and uses 30 of the burners you see on the left for gas combustion. So the results of this redesign they went through, taking apart from the original conventional thinking to the new additive manufacturing thinking, is pretty impressive. They make them in less time, they perform better, they weigh less, and they're easier to maintain. And all of this, of course, was done inside of Siemens NX. And by making these design changes, like, for example, moving the pink pipe you see on the very left-hand image to the internal structure of the burner, they also improved the safety of the final part by reducing the chance for leaks or breaks in the line. And this type of rethinking of the entire design is only really possible with additive manufacturing as the final production process. And again, using Siemens, our NX tool, they were able to take this design from what used to be a fairly complex assembly they had to weld together into this one piece part, and have improved their design quite a bit in the process. So very impressive stuff. Another example from our power division, this is a different type of burner. The objective here was to figure out a more elegant design for this burner because it took a lot of manufacturing effort to make this original version. And of course, you can't sacrifice performance during that redesign. So in this case, this burner is used to turn dirty waste fuels into power through a very efficient burn process. And what you see here is the original design of the burner system. So on the left, you see the tip that delivers multiple reactants to the combustion chamber. In the middle, there's a network of ring-shaped channels that transfer those reactants and cooling water. And then on the right are all the flanges that connect to the supply system. So this original design was made by welding together the series of concentric pipes and these machine components. And you can see that the shape and design was dictated by how this part is manufactured. So the challenge was, how do you redesign this to reduce the cost of manufacturing it while maintaining the performance? So here's where the aha moment came. Somebody, I guess, was probably making dinner and started thinking about this, and they saw, a funnel and thought, well, what if we could, kind of take that internal area of the funnel, how it twists and rotates around itself, and use that as kind of the inspiration to redesign. So additive manufacturing empowers us to create these sorts of shapes that we never could have been made using traditional manufacturing methods. And they used NX to create a parametric model of this new concept. And then they took it one step further. They very quickly achieved their optimal design by letting the computer do a lot of the work. They did this with the digital twin. They linked this parametric model in NX to our other products, Star CCM Plus for CFD analysis, and then HEEDS to explore the design space of possible solutions. And those two together came up with a highly efficient design for the internal channels inside of this particular burner head. Now, Star CCM and HEEDS are two other Siemens products, but they allow you to optimize designs using methods other than topology optimization, but again, coming to a solution that's optimal for the requirements of the various different situations. And this is the final result. So you may have heard the phrase, with additive manufacturing, complexity is cheap, and this is one of those things that kind of proves that case. We have a new, more elegant design that compresses all of the complexity of that entire system, original system, down into the small head of the burner that's now 3D printed. And this was done with a significant reduction in manufacturing effort and cost. So over 50% reduction in the number of welds that was required to assemble the burner, less than half the number of parts that were present in the original design, half of the size of the original design. And in the process, the team also identified a number of improvement opportunities across design, manufacturing, and even business. So as I stated, at Siemens, we don't just make software for additive manufacturing. We actually use our own software to make these awesome parts in our daily business. And we're creating these amazing 3D printed parts in an industrial fashion with our own tools. So just to summarize where we're at Siemens, we're working hard to industrialize additive manufacturing. We really believe that this technology allows our customers to reimagine the products they produce, to reinvent the way those products are manufactured, and even to rethink how they do business. So we want industrial additive manufacturing production to become an everyday occurrence. But to get there, it's going to take tightly integrated software processes to enable and drive that evolution from prototyping and one-off custom printing to true industrial scale production. And that's why we've worked hard to ensure that our Siemens NX product is uniquely positioned to enable this sort of industrial additive manufacturing future with our end-to-end integrated additive manufacturing process. Now, if you'd like further information about what we have going in the additive manufacturing area, please have a look at our community page. You can find our manufacturing news blog there, where Siemens employees, including yours truly, post about the latest we have going on for additive manufacturing. You'll also find posts about upcoming webinars in this series, notifications about the conferences we'll be at, trade shows we'll be attending, and much more. So I've been posting quite frequently here. I've actually had a series of blog posts about additive manufacturing in various different industries and the examples we're seeing there. So we try to keep this pretty active as far as additive manufacturing news goes. So it's a good resource for anybody who wants to understand what we're thinking about additive manufacturing and the things we have coming up. Speaking of things coming up, should you happen to be at Rapid in the U.S., I'd like to welcome you to come by and say hello. We are going to be there. We have a booth that's just inside the door. You probably can't possibly miss us, I guess. I will be there in person. I'll also have a session on Wednesday. So I'll be there, I think, throughout the entire Rapid event. And if you have any questions, please stop by. I'd love to meet you. We'll be glad to help you in any way we can. Understanding how we feel, what we think about additive manufacturing, how our software works. You can see it all in action there. Also, during that same week is Hanover Fair in Hanover, Germany. And I don't have a slide for that, but we always have a huge presence at Hanover. For Siemens company-wide, it's our largest single event, and we usually have a huge spread there. I believe we're going to have actually 2 separate areas at Hanover Fair this year. So you definitely can't possibly miss us there. But additive manufacturing will be a large part of the story that we talk about at Hanover this year, as it was in years past. So there will be experts in AM and experts in the Siemens software there on hand. So please feel free to stop by there as well. Again, I don't have a slide for that. I don't have the booth number or anything, but we'll definitely be there at Hanover Fair, and you can stop by and see us there as well. And if you'd like to connect with me, the best way, honestly, is by email, but I can be reached at ashley.eckhoff@siemens.com. But we also have phone here as well, and again, there are some websites we have where you can go for further information. So with that, I think we'll switch over to Q&A.
Wonderful. Thank you, Ashley. Let me take back the ball. I'll put you on mute. Superb presentation. Give you a moment to take on some water and have a breather. You have been speaking for around about half an hour or so. Superb. Thank you for covering what's quite a complex topic in a succinct way. Okay. Just to remind you that we do have a Q&A portion towards what we are now in the end of the webinar. It's your chance really to get the answers that you need for your process. Please feel free to pick Ashley's brain and anything that you'd like us to highlight, to clarify, to delve deeper into for you. Please feel free to send in your questions. Just a quick note as well to those sites that Ashley mentioned. As you can see, I've put the links up. I will be putting those links inside the chat window for you just after the Q&A and give you a chance to jump on and check out those sites. Okay, Ashley, let's go ahead and unmute you and delve straight into the very first questions that come in. Okay, a couple of questions here. I'm going to group them together. Within the additive manufacturing software area, what would you say are the new capabilities that one should be looking out for in the near future? So what are the new capabilities coming up?
That's a good question. Well, I guess what you'll see in the mainstream press is a lot of things like generative design, right, is getting a lot of mainstream press. And those capabilities are definitely really interesting and certainly will have a place in additive manufacturing. But what we see becoming important in a more widespread fashion is simulation, and not just simulation of product performance, but also simulation of the additive manufacturing process itself. For example, if you're simulating the printing process, it's allowing you to identify areas of the print that may distort or warp, and to correct the printer instructions for that area to sort of mitigate that issue. And upfront simulation combined with in situ monitoring, those sorts of things can generate sort of a positive feedback loop that improves the quality of the entire process. And this is the type of thing that, again, has to happen to enable this industrialized additive manufacturing that we envision. And it's the type of thing we're working on in our own software here at Siemens. So I think, you get a lot of press about the flashy things, but it's kind of the behind the scenes, real bread and butter type improvements to the process that will be coming through software that we're pretty excited about internally here.
Okay, thank you. I know we don't really comment too much on competitors, but how would you see Siemens products within the AM area comparing to other products on the market? How are we doing? The additive market is quite broad. There are a lot of, I guess, what you call niche products in this space, right? People who do one thing and do it really well. And we believe our individual solutions are mostly competitive with the majority of those products, right? So like I said, we've got pieces, right? You'll see lattice structure design and other products, but they'll just be a lattice product. Or you'll see topology optimization, but it'll just be a topology optimization. And we realize we can't possibly cover every detail from every one of those solutions, right? So we understand that there is going to be a certain segment of our customer base that needs to use a niche solution here and there to take care of some detail that maybe we don't cover. But I guess this is another reason why things like the convergent modeling technology I talked about are really important, because it allows you to easily take the data from those external systems and use it as seamlessly as possible in your everyday CAD work. Now, of course, that being said, we prefer our customers to utilize our solutions, but we also recognize that we aren't the only vendor in this space, and we want our customers to be able to use those solutions as easily as possible. In the meantime, we're working to make our integrated solution so wonderfully compelling that our customers hopefully won't want to use those other solutions, or if they do, they'll find themselves using them less and less as we add capabilities to our nice integrated internal solution. Wonderful. Thank you, Ashley. I know we've been speaking for quite a while, but probably just a couple more questions. Just to remind everyone, please feel free to send in your questions. If we do run out of time, no question goes to waste. I will be collating those down, and Ashley will provide answers over the coming days, I'm sure. Okay. Question here: is it obviously possible to create production parts with additive manufacturing? Is it something that the average company should expect to achieve in the near term?
Well, that's a good question. So I guess one of the hurdles we see companies facing when they start to adopt additive manufacturing is getting the right set of resources to work together, right? The hardware, the software, and even the people and the know-how, right? The hardware and software are coming together nicely, but the know-how is the aspect that I guess many companies are still missing. If you want to create production parts in the near term, and you haven't done any of this before, you might actually be best served to contract with a service bureau, at least at the beginning, and then move the process in-house if you want, after you've gained the necessary process knowledge and established, proper design, analysis, and manufacturing procedures around additive. The real value here comes when, like we said before, when companies start adjusting their design, their manufacturing, and their business processes around additive, but that really can only come after you've gained some experience. So, we're creating production parts today, but that capability came after painstaking research and knowledge acquisition about how additive works and the types of parts that are possible to produce. So, companies need to build up that knowledge. And so at the beginning, we talked to a lot of companies who use these service bureaus as sort of their entryway to gaining that knowledge. They can learn about what parts work, which ones don't, how much editing the service bureaus have to do of a part before it's produced. And they take that knowledge and start building up their in-house know-how about how this is all done. And when they feel comfortable, then they can start investing in hardware of their own.
Okay, wonderful. Thank you, Ashley. Probably just one more. Again, thank you. What portion of the market do you see actually printing production parts? So, for example, in metals versus the portion that is doing mostly prototyping. What sort of split do you see there?
Yeah, we still see a lot of prototyping in the market. The number of companies printing production parts is still pretty small when compared to the number of companies doing prototypes. However, we are seeing an increasing number of companies talking to us about this and taking this on. So as we've introduced functionality in our software to support this industrialization of printing, we're seeing a lot of interest in our vision for how this is going to play out. And in particular, we see customers who are just beginning to experiment with things like metal printing in production parts. And again, like I said, often partnering with the service bureau to start out. But allows them to create low-volume production parts without the overhead of buying, setting up, and learning about the printers. And this type of interaction is becoming more prevalent, and it's actually coming online a lot faster than we expected. And as far as we can tell, it's only going to increase, which is why we've made the investment in industrialization of additive manufacturing, and we talk about it a lot as a major emphasis for us because that train's left the station and it's barreling down the track, and we just see it accelerating for the near future here.
Wonderful. Thank you, Ashley. Thank you. I know you've been speaking for quite some time. Thank you for donating a small portion of your knowledge to answering the Q&A section. Thank you, much appreciated, and thank you for your superb presentation. Okay, just a quick note on Q&A. We will be collating your questions down. We will provide you with answers over the coming days. Just to the two gentlemen that submitted questions in the chat window, if you could put them into the Q&A window, Ashley should be able to see them. Also, those links, I provided those in the chat window. That's the Additive Manufacturing Info site and the Siemens community site. Those links are there, but obviously please feel free to contact me should you require those. All attendees will receive a follow-up email from myself containing a link to the recording of today's session. I should hopefully have that out by this evening, if not tomorrow morning. If you wish to reach Ashley or indeed would like confirmation of those links or any other information, you should have my details by now. I think I've left out a point in there, so it should be j.dunstan@siemens.com. Please feel free to contact me and your gateway through to Ashley and any other additional information should you wish it. If you would like to see any of our products, please go to our Siemens store. Again, you can find a whole host of information there. Just go on the internet, go to siemens.com, PLN Get Now, and you'll find a whole host of info there for you. So it just remains me to say thank you to Ashley Eckhoff, and of course thank you to you all for giving us just under an hour or so of your time.